Okay, so we're going to use the idea of squares and square roots for something called the Pythagorean Theorem, which is something you will learn to either love or hate over the next few years. People don't seem to tend to fall halfway in between on these ones. But we can use right triangles to find the length of a line segment, which is a lot easier than what we just did with making a square. So a right triangle is a triangle with a 90-degree angle. So basically it's half a rectangle. The two sides that make the angle are called the legs. And the third side, so that's the one opposite the right angle, so here's the right angle here, and the one opposite is called the hypotenuse. The hypotenuse is always the longest side of a right triangle. So here's an isosceles right triangle. That just means the two legs are the same length. Here's a scalene right triangle, which means the two legs have different lengths. You will always have either isosceles or scalene right triangle. For this next little bit, I want you to work on your own, or you can work with a partner if you like, but I prefer if you do it on your own. So copy this line segment here on grid paper, and then you're going to draw a right triangle that has AB as a hypotenuse, so it's going to look like that, or it could be on the other side, doesn't matter. I'm going to draw a square on each side of the triangle, and you're going to find the area and side length of each square. I'm going to draw three different right triangles with a square on each side. Find the area and length of each square and record your results here. When you're done, I want you to compare the results with another classmate. And what relationship do you see among the areas of the squares on the sides of the right triangle, and how could this relationship help you find the length of a side of a right triangle? I need you to pause the video now, and I need you to do that and come back to that later. So now that you've done that, and if you haven't, please stop the video now and go back and do it. Here's a right triangle with squares of each side drawn in. So here this one has a side of 3, so we made a square, so it has an area of 9. Side of 4, made a square, area of 16, and 5, area of 25. You'll notice that 9 plus 16 equals 25. Every single right triangle has this relationship. So if you square the lengths of the legs, and then you add those squares together, it will be the square of the hypotenuse. This is called the Pythagorean Theorem. And you probably don't have enough room to write that here. It was named after Pythagoras, who was a Greek mathematician who made it well known. So he probably didn't actually discover it. There's evidence to suggest that that was around before he came, but he studied it and he used it a lot, and his name got attached to it, so everybody now knows who he is. We don't know who thought up in the first place, but we call it the Pythagorean Theorem. So if we want to find the length of the hypotenuse to one decimal place, so we have 4 centimeters here, so we would figure out the square there. So 4 squared plus 4 squared, because we got another one here, is equal to, and I'm going to call this h squared. Okay, so that's 16 plus 16 is equal to h squared. So h squared is equal to 32. So that means that this square is 32 centimeters squared. So what is h? Well, to find h, we need to find the square root of 32. So h is going to be equal to the square root of 32. And that one I'm going to do in my calculator, but if I think about it, 32 is between 25 and 36, so I expect it to be 5 and a bit, probably somewhere around 5.5-ish. So what are we at? 32, and I want the square root of that. And it's 5.65, so one decimal place would be 5.7. You'll notice I often put a box around my answers. This is a really good habit to get into for lots of reasons. one of them that pertains to me is if you're doing a quiz and I'm marking it, it's easy for me to figure out what you thought was the answer. Let's go to the next example. We want to find the length of the third side to one decimal place. Now we look, this is the hypotenuse here because these two sides here make up the right angle, so those are the legs. This side is the hypotenuse. So I know that this triangle here would be, or triangle, pardon me, square here would be 25. This square here would be 100 because it's 10 times 10. And I have no idea what this square would be. Well, 25, let's call this, it doesn't matter. 25 plus this question mark would give me 100 because that's the rule. If I square this and I square the two legs and add them together, I get the square of the hypotenuse. So let's call this side A, and then we're going to call this A squared because it would be whatever that is squared. So I'm just going to erase this and make it A squared. Well, 25 plus A squared is 100. So if I know I add those two things to get 100, then to find that I would subtract. So A squared, so that square is going to equal to 100 minus 25. Well, that's 75. So I know that this has to be 75 because 75 plus 25 is 100. But I don't want to know the area, I want to know what this is. But I know that this is the square root of that. So A is going to be the square root of 75. Again, 75 is between 64 and 81, so it's going to be 8 point something. Closer to 81, so it's going to be over 8.5. 75 square root is 8.66. So it's going to be 8.66 would round up to 8.7 centimeters. And let me change this. I won't take marks off for it, but again, good thing to get used to. It's not exactly 5.7, it's about 5.7, so we shouldn't technically say it's equal. Same thing here, shouldn't technically say A is equal to 8.7. We have now rounded it off, so technically we put little wavy lines in. Not going to dock you guys marks for it, but something that's good to know. There's your practice. There's your extra challenge.